Hello and welcome to helpyourmath.com. In this video, we are going to look at simplifying expressions using the properties of exponents, where we have to use the distributive property of exponents over multiplication. So if we see something like x times y to the b, we distribute that exponent of b to all of the bases. Now, if what we have inside parentheses has exponents, then we would apply power to a power and we would multiply the powers. As it stands now, we're just going to distribute to each unique factor. So we would have x to the b times y to the b. And then we would simplify from there. Let's take a look. We want to simplify the rational expression and write the answer using positive exponents only. I have three unique factors, or three unique bases, I should say, in this set of parentheses. 16 is one of them, x to the negative 18th, and y to the negative 26th. So we're distributing this 3 halves 3 times. The 16 currently has an exponent of 1, so this is going to become 16 to the 3 halves, and we're going to fix that in just a minute. X to the negative 18th, we're going to distribute the 3 halves to that, and what we're going to do is we're going to multiply the exponents. So for x, I'm just going to come over here, we're going to focus just on the exponents. Remember, for power to a power, we multiply. When one thing I'm multiplying is a fraction, I want to turn everything into a fraction. So I'll turn negative 18 into a fraction by putting it over 1. And then 2 will cancel out and become a 1, and 18 becomes a minus 9. Negative 9 times 3 is negative 27 over 1 will just be negative 27. So x, we have negative 27. And now let's look at y. So y, the exponent we currently have is minus 26. We'll put it over 1 times 3 over 2. The 2 cancels, and the 26 would become a 13 when we divide it by 2. Multiplying straight across, negative 13 times 3 is negative 39. Divided by 1 will be negative 39. So here we get y to the negative 39. And the 16 to the 3 halves. Let's look at that now. Generally, when we see a question like this where we have a fractional exponent, the base that we're given, in this case 16, should be a perfect, whatever this denominator is, power. So we assume, or we think, or we hope that 16 is a perfect square. And it is. It's 4 squared. So we're going to take 16 and we're going to rewrite 16 as 4 squared. And now, just like we did with x and y, we have power to a power. We want to multiply the exponents. So just looking at the exponents, we have 2, which we'll rewrite as 2 over 1, times 3 over 2. Well, those cancel, and we just get 3. Remember what the base is now. We rewrote it from 16 to 4, so it becomes 4 cubed. Okay, so now what do we have? Because we do have some bases with a negative exponent, I know that we're going to need a fraction for our final answer. And then 4 cubed has a positive exponent, so it would stay in the numerator. We could also write 4 cubed, that's 4 times 4 times 4, as 64. X to the negative 27th has a negative exponent, so when we create a fraction, it's going to go in the denominator, because otherwise it would have been in the numerator with that negative exponent. Same with y to the negative 39th. We can't simplify this any further, so we're just going to put a box around it and be done. This has been an example of distributing a rational exponent to other exponents. Thank you for stopping by.